Welcome to the Engineering Economics course. Welcome to the lecture number 7. We are going to see is the debt management. What is this concept of debt management? Is the concept of knowing the internal numbers and calculation that you have to do when you are you have a debt, and then you are paying part of the principal amount you borrow it, and you are paying interest every month or every year. So we are going to learn and to know how to calculate those interest payments and those principal payments, and how a loan or how a mortgage is amortized over time. So this is the recommended textbook for this course, the Chan S. Park Engineering Economic, Fundamentals of Engineering Economics from Prentice Hall. So what is the concept of a debt? As we know, in general view, we have known that a loan is an amount. A debt is an amount of money we have borrowed from a financial institution, like a bank, for example. And then this amount we borrow is, we have borrowed, this amount is a debt. Why do need, or what does the financial, financial institution they provide, they lend money? Why? Because individuals or companies and all, even the state need, all of us, we need money for buying long-term assets, like, for example, buying a house, buying a new machinery, building a new facility for a company, and so on. So that's the kind of long-term asset we buy as individuals or as a company. And also we as individuals and companies, also they borrow money for short-term needs they have, for paying the next credit card, for paying the next month's expenses you are going to have, you pay with your credit card, so you get you borrow money from for a month. Or for example, when a company in their daily operations, they have cash receipts and cash disbursements, and they don't have enough cash because their receipts have delayed, and then go to the bank and ask for a credit account, and then they give you money for 1 month or 2 months, and of course all this money lended is charged with an interest rate. So another important fact in debt is that the institution who has borrowed with you the money, who has lended the money, they want to have a guarantee of that their money is going to be returned. So that guarantee is what we call the collateral of a debt, and usually the collateral of a debt, sometimes, for example, in the case of mortgage for a loan for buying a house, the same house acts as a collateral. So in the case of delinquency, so in the case that the lender, the borrower has not paid the mortgage after 3, 4, 5 or 6 months or 1 year later, the bank can get this guarantee, this asset. In the case of a mortgage, the collateral is the same house. So, but also we have to know that in real life, that not all the assets are bought with debt, because some of the asset investment are paid by the owners, ourselves, or by the shareholders of a company. That's a portion of money is the equity. So part of the asset price is paid by the shareholders in terms of equity, and the other part, the remaining money, is paid with debt. So they go, the firm go to to a bank or financial institution, and they get a loan from them. So what is the concept of equity and debt? Sometimes when we will be analyzing companies, they have a portion of their investment is financed with equity, with their own funds. Another part is financed through the debt, through the money borrowed from financial institutions. So that proportion of equity and debt is what we call the leverage of a company. Just to have to give you some culture concept. This is the leveraging of a balance sheet of the company. Is the proportion of debt, the proportion of capital, total capital of the company. In general, can be said that this is debt plus equity, and then the proportion of debt divided by the capital used. This proportion is the leveraging. So we are going to know the essentials, the fundamentals of a loan, of paying back a loan. In general, we call this kind of loan that we pay off, this is an amortized loan. What is an amortized loan? All the loans, the more complex, the most complex, the more simple from us, or the more complex, all of them, they have the same elements, 3. Which one? The first one is the amount I have borrowed, the principal, P. The second one is at what cost I have borrowed that money. This is the interest rate. And as always, we are using compounded interest rate. And also an important parameter of this one related with the interest rate is when or how often I repay the debt. This is the repayment period, so it's the number of periods per year, can be 1, or per year I pay interest one time or principal once a year, or I can pay every month, so 12 payments every year. And the third parameter important is the term, the length, the duration of the loan. So it's the time I have to return to give back to the bank the principal. The most important fact of an amortized loan is that every repayment period we pay an equal and constant number. So every month for our mortgage we are charged the same amount. So this is the most important fact of an amortized loan. The periodic and equal and constant amount I pay every repayment period. How is it composed, this constant amount? This constant amount, for example, every month, is composed, this constant is composed of 2 different portions. Which ones? The first one are the interest payments. So, as we have borrowed money, we have to, for the money borrowed every period, we have to pay the cost of this money. What is the cost of money? Interest rate. So, as much money I have borrowed, as much interest payment I pay. So, how do I calculate the interest payments? The interest payment in any moment, in the time t, is equal to the interest rate times the outstanding debt. What is the outstanding debt? This is a concept from banks. The outstanding debt is the amount of money you owe to the bank in the first month or first day of this period. So this is the reason, is the debt in the time t minus 1. And the other portion of this equal and constant payment, the first one is the interest payment, and the second one is what we call the principal repayment or amortization. So at the end of the term of the loan term, I will have returned all the principal repayment or the principal, because I've been paying every month or every year. I have been paying a portion of this principal amount. This portion is the principal repayment we call lower P. What is important for an amortized loan is the sum of this constant figure is constant. Let's say, for example, A. This periodical and constant amount, A, is composed of two tranches. I have explained it, the interest payments and the principal repayment. What happened is that the portion of these payments varies according to time. So at the beginning of the loan, we will be paying lot of interest because we owe lot of money to the bank. And then as this the principal amount is returned, the outstanding debt, the outstanding amount I owe to the bank will decrease, and then the interest portion will decrease. And as the payment, the periodic payment is constant, if the interest payment decrease over time, what happened with the principal repayment? That they will increase over time. So that's the idea of the constant quota. This is the French system of paying a loan, the French system, that we pay a constant loan, a constant amount, or monthly repayment is constant every period. Of course, if the next year I have an agreement with my bank that the interest rate are variable, next year my bank will review this interest rate according to the market interest rate at that moment. So that's the reason our payment is not constant over the time, because we have variable mortgage or variable loans, and then every period we have a reviewing period, and every period our bank changes the interest rate. So as I have said, being the monthly amount a constant, what happens is that the proportion of interest tranche and the principal repayment tranche, the proportion is variable over the time. As I have said, in the first period of the loan, we pay a lot of interest. Why? Because we owe a lot of money to the bank. The outstanding debt in the first months is quite high. And then, as the monthly payment is constant, then if we subtract the constant number, A, minus the interest payments, and then this amount will be the principal repayment, and then the small in the first period and a small amount of principal repayment is produced. Inversely, in the last periods we pay lot of principal and a small amount of interest. Of course, know please that there are another payment schemes. This is the payment of a loan. This is the cash flow diagram. This is the amount we have borrowed today, P minus P. And then this is for the term of the loan, the N, year. We have constant and periodic every year or every month, constant amount, A. So, if we calculate the proportion of this amount A, what is the proportion of P, principal repayment, on the interest repayment, if we see over the time, we see that in the first period, the tranche of interest is much higher than the principal amount, which is this one. So at the end, most of the payment is principal and just a small amount of interest. Why? I have explained it several times. Because the interest payment every period, for example, let's say in year 1, interest payment in year 1 is equal to the amount of money I owe to the bank, let's say in the year before, D0, times bracket 1 plus the interest rate I have agreed with the bank to the power of 1. Excuse me, to the power, excuse me, this, I have to delete this one. The interest rate is in year 1 is equal to the last period debt, outstanding debt, D0, times the interest rate. So this formula, the interest rate is equal to the I, excuse me, this is lower, misprint, I plus times outstanding at the beginning amount. So as the constant is the payment, the periodic payment is constant, then what is the value of principal repayment? Principal repayment is the constant payment. I have agreed with the bank, A minus the portion of interest. So that's the reason of this shape. How do we calculate? This is the one important thing, is the calculation of interest tranche, the calculation of the principal repayment, and then we have the main question open, is what is the value of this constant payment? What is the value of A? What is the value of A? We know that from lecture number number 4, the different equivalent formulas for different cash flows. Do you remember which cash flow seems this one? We are saying that we know the present value, the value of the loan, P, and we know the future value. What is the future value at the end of n years? The future value of our loan, we hope to pay off at the end. So future value is equal to 0. So we know the interest rate, we know the number of years, we know the interest rate, we know the present value, we know the future value, and what is unknown is the amount. So you remember that we are given 4 of the elements, and we have to know to calculate the 5th element, which is in this case the A term. The A term is equal to the formula, Excel formula, payment, periodic payment of n number of years, I don't remember the order, please review yourself, the interest rate, the minus present value, the value of the principal, the future value 0, and the method of calculation, which is 0 also. So that's the way we calculate the periodic payment. So let's calculate a debt, cash balance. So we have here the payment of a loan with the French methodology, which is the constant repayment. So we have to calculate. We have to calculate the principal amount. The constant repayment. We have to know for every period. We have to calculate the interest repayment, and we have to calculate the principal repayment we are making every period. Remember please that the calculation will be A and I, and then we will derive from those variables, we will derive the principal repayment amount. So this is the principal amount. We get a loan of 100,000 euros. We agree with the bank to pay in 10 years, so term is 10 years. The interest rate is 5.50. Let's think that they are periodic payment every year, so not monthly payment. So the number of periods per year is 1. Just the only difference will be that in the case of paying 12 payments per year, we will be use an interest rate equal to the interest rate E sub monthly, equal to the E, which is annual 1, divided by the number of periods, payment period, which is 12, so it will be 5.5 divided by 12. So it's the only difference. So let's think about one payment per year. The outstanding beginning of the year, we have here the number of periods, the number of years, from 1 to 10. If the case would be 12 payments per period, so we have to extend this calculation to 10 years times 12 months, 12 payment per year, so this index will reach the number of 120. Forget that at the moment. Come back to the 1 year period payment. So we have, at this moment, we receive, the end of this moment, we receive the loan, all the loan, 100,000 euros. So at the beginning of the next year, we will have this same 100 euros, 1,000 euros, we owe to the bank. And then the first thing is how we calculate A. Okay, so we have several methodologies to calculate the periodic payment. You see here all the years from now to 10 years from now. The periodic payment is always constant, which is 13,267 euros. So we have three options using tables, like in the Park book. We have the option of using directly the formulas. We have the other option is using Excel, and we have other option is using a financial calculator, which is my most preferred option. And so we are going to use our calculator for finding the value of A. Please. So we are commuting the video to see the calculator. So you are seeing the calculator. So this is an app for an iPhone. You have also for the Android smartphones, and this is for iPhone. You are seeing what are you watching in your screen is an iPhone with an app. This is the app of the BA2 Plus Professional from Texas Instruments. This is the calculator. So you are seeing the app that emulate or simulate this calculator, this financial calculator. Also you have apps for the HP 12C, which is the other most common used financial calculation. So let me explain how to use this financial calculation with this loan. So you see here all in the third row, 1, 2, and 3, in the third row with green keys, you see NI/Y, PV, PMT, future value. Those are the keys, the 5 keys we always use in time value of money. So we know the number of years. So we are going, let me to clear the time value of money calculation. This is the yellow one, second function, and then clear TVM, this one. Okay, so number of years, 12. Excuse me, 10. And then press N. Interest rate, as we are using annually payments, so I'm going to use directly the interest rate, 5.5, and I type the same numbers of percentage, so I don't use 0.055. No, so I use 5.5 because the key I/y is expecting to use this in percentage. So as you see here in the screen, the interest rate is 5.5. And then I give to the financial calculator the present value. This present value is the principal amount I'm borrowed today. So I can use, always keep in your mind that you need to use minus or positive sign. So I'm going to use the principal as in our cash flow here. In our cash flow, we see that the minus, the principal amount was in negative. So I'm going to write the principal amount with the minus sign, you see here, and then pressing the present value key. You see here, present value equals to minus 100,000. And then the future value of the loan, if I pay all the amount, all the loan at the end, is 0. So that's the future value. And then just is to calculate, to compute, using the compute key, which is on the upper left corner of the calculator, the PMT, which is the constant and periodic payment. PMT is payment. So compute, and then PMT key, and then you see that the payment, periodic payment, is 13,269.66. So it's the same number you see in your slide, your paper, the screen. You see this is the periodic repayment. So please come back to the slide. Thank you. So we see again the slide. Remember that number A, 13,267. So that's the best way to calculate. And then let's continue to understand how this payment, periodic payment, this amount is composed over the time. So as you see here, this column, the I column, this is the interest portion. How do we calculate the interest portion? As you see here in this box, the I portion is equal to the interest rate times the outstanding beginning balance of the money. So as in the first year, after the first year, so the end of the first year, I owe from the beginning of this period 100,000 euros, the amount of the interest repayment is the interest rate, 5.5%, times the outstanding beginning. So if you multiply 5.5% times the outstanding balance at the beginning, outstanding debt at the beginning, 100,000, this is 5,500 euros. And then, what is the principal repayment portion? As we know, the principal repayment is the subtraction of the constant amount minus the interest portion. So the principal amount I repay in the first year is 7,767 euros. So what is the outstanding debt? Is equal to the outstanding debt at the beginning, 100,000, minus is the money I owe to the bank at the end of the year. So if I started owing to the bank 100,000 euros, and then I pay part of this principal amount, I pay this year, I have paid 7,767. So at the end, if we make this subtraction, I will owe to the bank 92,230 euros. So this amount is the ending amount of the year 1, and this amount will be the beginning amount I owe to the bank in the second year. This beginning debt, this beginning outstanding debt, will be the amount I will be owing to the bank, and then the bank, I have to pay to the bank the cost of owing that money, and this is the interest branch. And then again, now the interest portion is equal to the amount I owe at the beginning of year 2, which is 92,230 times the interest rate, 5.5%. If you multiply that, it gives you 5,073 euros. Again, the principal repayment is the difference between the constant amount minus the interest rate. So as you see, the interest portion has diminished, has reduced, and the principal amount repayment has increased. So that we have explained it, that over time, the interest tranche decrease. At the end, the last year you will pay just 692 euros, but the principal amount, conversely, is the opposite. It will increase from 7,000 to 12,000. So at the end of the 10th year, the amount you owe to the bank after starting the 10th year owing to the bank 2,575 euros, after paying the principal amount of this year, which is 12,575 years, this equals to 0. So at that time, the outstanding debt you owe to the bank is 0. So you have ended to pay the loan. So at the end, if you add all the principal repayment every year, you will see that this adding is 100,000, the same amount you borrowed. How much have you paid in terms of interest? You can sum all the interest every period, and you will have paid 32,000. So at the end, the amount of money for lending, for borrowing 100,000 euros, the full amount of money you have paid to your bank is much higher, is 132,000 euros. So 32,000 euros more than you loaned, but this is the business of bank, of course. If you have money, you have 100 euros, don't ask money for the bank. If you want to buy money, you want to buy 100 euros and then having 10 years to return that money, the cost of using that money during 10 years, that the interest payment you have to pay. So as you see, remember to use, this is important, the correct interest rate per payment period. So for example, in case of 12 payments per year, so monthly payment, the interest every month will be 5.5 divided by 12, which is 0.45%. And then using this formula for n equals to 1, to 0, to 120. Why 120? Because this is 10 years times the number of periods per year, which is 12. So with this simple example, we know a lot about debt and about loans. So you see here the proportion. This is the principal amount, and you see that the principal amount increase over time, and this other portion, this is the interest portion, you see that this the interest portion decrease. The interest portion. Why? We have explained it. And you see here the formulas. Use please the reference, this one, this is A, B, C, D, E, and F, and this is row 1, row 2, row 3, row 4, 5, and then you will see here that the payment, this column, this is the constant payment. I have showed you before with the financial calculator. Just you can see here with the Excel formula, which is PMT in English, and the PMT equals to the B3, which is this is B3, absolute reference, in order to iterate along all the rows. The interest rate, B2 is the number of periods, 10. B4 is the principal, excuse me, B4 is the number of periods, excuse me, this is B2 times, okay, this is B2, number of years times number of periods per year, so the number of periods is this amount, and then B1, which is the principal amount, B1, 0 for future value and 0 for the method. And then you iterate in order not to have moved the fixed cell of interest rate or number of years. Then you write $$ between the two possible iteration in the column or in the row. And then you see the interest rate, how is it calculated, with the payment interest, excuse me, the payment of interest formula in English, and in Spanish this one is the same always, but as you see here, we have here B3, which is the interest rate, and the iteration cell in this case is A7. A7 is this one. This is A7, so we are iterating this cell, so we don't use $, and then we are saying calculate the interest payment for the period 1, for the period 2, for the period 3, for the period 4, which, as you know, depends on the period this interest payment. And then you see here constant with absolute reference the number of periods times the number of payment per period, and then the principal amount B7 excuse me, B7 B 1 2 3 4 5. This is B7. 1 2 3 4 5 6 7 6. Let me see the Excel. Keep, and then okay. So I'm seeing in big numbers. Oh, lovely Excel. Please wait. Okay, it's here. Oh, I think sometimes the Excel files inserted in onto the PowerPoint sometimes creates that kind of problems with memory and so on. No. Okay, so you have here the formulas. Try to understand them, but they are quite straightforward. You see here the formulas for Excel. The Excel formulas are those one. T is the long term. K is the number of premium periods per year. N is the number of payments. So T times K is the number of periods of payments. I is the periodic interest rate. E annual is equal to the E annual divided by K is the periodic payment. P is the principal, and N is the period. So the payment, the periodic repayment, the constant periodic repayment is the interest rate of each period, the number of periods, taking into account the number of payment periods, the principal value, and the future value 0, and 0 is the methodology. What is the principal repayment amount? You can have this formula in Excel. Is the PPMT, and this is the P of principal, is the interest rate, the number of years, excuse me, the year, the time you are using, for example, n equal to 3, if you are calculating the principal repayment as GR3, the principal amount, 0 the future value, and 0. And then as n change every period, then you will have different principal payment. What is the interest repayment? Is the interest repayment IPMT is the same logic, is that n is different from each times of period. If you want to know how much interest have you paid till certain time, you can have the cumulative interest paid, and you have also the cumulative principal interest rate. So let me explain with the calculator, please, of the previous payment. Please go back to return to the slide number 7, and then I'm going to use the calculator. I have in the calculator, in the financial calculator, I have introduced the example numbers, and then what I'm going to know is the amortization table. I can have it, I can get it from the calculator. So let me explain. I have introduced the number of years, the interest rate, the present value, the future value, and we know the payment, the periodic payment. So second function, the yellow key, amortization, which is the present value account, it gives you, excuse me, okay, so second, excuse me, is the cash flow key. Press on the second row, the second column, the CFI, cash flow, and you see here that the cash flow, okay, and let me see, okay, and recall payment, okay, recall present value, okay, so then the cash flow. cash flow 0, and then we want to know the beginning balance in year at the end of year 1. So I use here the C01 parameter. You have to learn how to use this calculator, and I will write 1, enter, and then the second year 1, excuse me, delete all, okay, recall present value, okay, recall payment, okay. So cash flow 0, excuse me, this is the amortization key. And then, okay, so I explain again. If you want to know the cash flows of a debt every time, you use the incorporated tables that the financial calculator has, and then you can get them using the amortization function, which is the third key of the third row, and then using the yellow function, which is the second, amortization. It asks you the period 1 you want to know. The period 1 must be in year 1 and the period 2 in year 1. So it gives you the beginning balance at the end of this period, which is 92,233 euros, as we learned in the slide number 7. And then you press arrow, okay, excuse me, second amortization, P1, P2, 1, okay. So, and then the principal amount you are paying, it gives you the right amount we have calculated, 7,766. The interest rate is 5,500, as the table in Excel table is calculated. And then if I want to know, for example, in year 3, the outstanding balance at the end of the year, so I will use P1 2, P2 2, and then it will give me the ending balance, excuse me, P, okay, so 2 for enter, P2 2, enter, okay. So the ending balance is 84,039 euros, as in the table is written in the page 7. And then the principal amount you have paid is 8,194, as the table says, and the interest amount is 5,072.8 euros. So as you see, with those financial calculators, you can do many things. So come back to the presentation, and then we are seeing a case is that this is a more complicated issue, is that we have a loan, we are paying every year an amount, and then in certain time we want to finish, to repay all the loan, all the remaining loan, all the remaining debt we have. This early payment is what we call the early repayment. So at certain time we were paying during it was forecasted to pay from year 1 to year end an amount, periodical amount of 417 euros, and then in year key you decide to end, to finish all the relation that you have with that loan. You want to do what we call an early repayment. So how we calculate this early repayment? So what we have to do is to calculate the present value of the periodic payments we owe to the bank in the next years from now, in the key year, from now to the nth year. So this is the number of years from the key year to the end year is n minus key. So the present worth of those periodic payments with future value, of course, of 0 equals to 0, the present value at the interest rate, and the number of periods is n minus key. So that's the way we can calculate this early repayment, and this is a lump sum. We know that what is that concept? Is single amount of money paying in certain time. So we calculate in that way this formula, and then we see here, for example, we want to know this ending lump sum. So we have a loan of 17,420 euros. The term is 3 years. I pay every month, and the payments are 300. The interest rate is 7%. So at certain time, so the number of periods would be 3 years times 12 equals to 36 periods. And then in the period n equals to 20, I want to pay the remaining 16 payments. 16 is equal to the total number of due payments, which is 36, minus the current period of time, which is equal to 20. So it remains 16 payments. So at this moment, n equal to this time n equal to 20, the early repayment is the present worth of the 16 remaining monthly repayments. So the present worth of the periodic payment, 300, of the interest rate, 7%, we remember is in monthly, so this is 7 is year annually, and then we divide by 12 to have the interest rate monthly, and the number of periods we have to calculate the present worth is 16, which is the number of years from now, 20 is time 20 to the 36 year. So this lump sum is 4,570 euros. Another example, the last one. Is a real example. You go to buy a house, to buy a car, and the car dealer offers you a loan. They have their own financial company, and they say those are the loan terms. You want to buy a car of a price of 27,420. You have money. You have enough money to do a down payment today of 5,449 euros. You are going to pay in 36 monthly payments, so 3 years at 12 months per year. The buyer, the car dealer says, okay, so you will be paying this amount today, the down payment. You will be paying also periodic payment during 36 months, but at the end you also have to make another lump sum, a final lump sum of 2,011 euros. So the annual percentage rate is 7%, and the most important thing in this example, until now, I think we know how to calculate those numbers. But the most important for this example is that we have that our bank, our car dealer, they charge us with a commission fee, a booking fee. They say, and the commission fee for the loan, they say the booking fee, is the 3% of the loan. And then you say, and if they have said that the annual percentage rate is 7%, and now, today, I have to pay another 3% in terms of booking fee, how much will be the interest rate I will be paying? Because it won't be 7%. No, of course, it won't be the 3%. So, the first question, the periodic amount I'm going to pay. How much will be you paying every month? The A payment, unknown. And how much is the effective annual rate? Remember lecture number 5, that as we are paying every month, so 36 years, we have the annual percentage rates. What will be the effective annual rate? And also, what will be the effect of the booking fee in the effective annual rate I'm going to pay? You have here the solutions. I'm going to explain how to do, and do it yourself. So the cash flow diagram is this one. You should see here the booking fees. You have the early repayment at the end of the 36 periods, and we want to know the effective annual rate. So you have a loan, you have a booking fee you pay today, you have periodic payments, and you have the lump sum. So all those cash flow we know how to handle, how to calculate. Let's start. The interest rate is 7%. The monthly interest rate, this is the nominal one, of course, the annual percentage rate, is 7 divided by 12. The number of years is 3, the number of periods per year is 36, is 12, so the number of months is 12 times 3. So we will be paying from now to 36 months, we'll be paying a certain amount. The car cost is this one, 27,420. I make a down payment of 5,484. So the final loan I'm asking to the car dealer is the subtraction of the car cost minus the down payment. So at the end, I'm asking to the bank for a loan of 21,936 euros. The booking fee is a 3% of the loan, so it means multiplying a 3% of 21,000, this is 658 euros. So the final lump sum I know, so those are known, is the lump sum. They have said that at the end of 36 months I have to pay 2,000 more euros. So the monthly payment, how is it calculated? The monthly payment, I'm going to delete. Okay. Now pointer again. Okay. So the monthly payment to calculate is this one, 376. Where does this calculation come from? It comes from the monthly payment, the formula of Excel of what? B3. Again, use the reference. This is the column A, and B. This is the row 1, row 2, row 3, row 4, row 5, row 6, 7, 8, 9, 10, and 11. It says payment of B3. B3 is the interest rate, the monthly interest rate. This is B3. B5, 3, 5. B5, the number of periods, which is 36. The amount I have borrowed, the principal amount, which is, I use the sign minus, B8. B8 is this one, loan. This is B8, the loan. And then B11. B11 is the final lump sum. So what I'm using in this monthly payment is, I know the present value equal to the loan. I know the number of periods. I know the future value I will owe to the bank, the lump sum, this amount, 2,000. And then I know the interest rate, in this case is monthly, so we know 1, 2, 3, 4, 5. Excuse me, 1, 2, 3, 4. And then the unknown element is A. So that's the reason I'm using here the present value, which is the loan, the future value, which is the lump sum, and then 0 for the method. And then the monthly payment, it results in 376 euros. So what is the real nominal interest rate I have paid? What I mean with real is the true interest rate I have paid. So we have several methodologies. I have used here the interest rate that gives us the Excel nominal is B5, so the number of periods, minus B12, which is minus the monthly payment. This is B12, the monthly payment. And then I have used the real amount you have borrowed from the bank, which is the loan B8, this one, minus the booking fee, minus this cell, which is the booking fee, the B10. Why I use that? Because this is the real value of the loan you have borrowed. And then the future value, the lump sum, B11, and then 0. So if you calculate this rate, this is 0.70. If you multiply by 12, the real nominal interest rate, the APR real, is not the promised 7%, because you are paying 12 times 0.7 is something like 8.4%, much higher than the 7%. Why? Because you are paying a 3% of in the concept of booking fee. So if we calculate the effect of this nominal rate, real nominal rate, and the effect of not using GR payments but monthly payments, that is the scenario, we use the effective annual rate, the year, and we use the Excel formula, the effective interest, and this is calculated quite straightforward with the interest formula. So with that slide, we have finished our lecture number 7, debt management. So thank you very much for your attention. We will see you again in the next lecture. Bye.